Hello students, welcome back to Physics with Ashwini. In the previous session, we understood the basics of motion in a plane and how to apply equations of motion separately in x and y directions, isn't it? In today's session, we are moving one step ahead and discussing a very important topic, projectile motion. Here we will discuss and understand how a particle moves when it is projected at an angle with the horizontal. So are you all ready? Shall we start this projectile motion? There is a figure on the board. Everyone observe it carefully and I want you to observe the length of the arrows as well. Pink color arrows, blue color arrows. Just see the length of the arrows and also the directions. So what is projectile motion? What is projectile first of all? Any particle which follows parabolic path. So what is this projectile first of all? This is any particle that follows parabolic path. As you have seen in the figure, what was the path taken by the particle? It was parabolic path, right? And parabolic path in the sense, what kind of motion? It is 2D motion. So we'll do the same concept. We'll divide the given data into x components and y components. Now imagine this projectile is projected making an angle of theta with the horizontal. Which is the horizontal? This is the horizontal. This is called horizontal. So the projectile was making theta angle with the horizontal with some initial velocity u. Now as this is a 2D motion, what do? We divide the given data into x and y components. Now what is x component of initial velocity? It is ux. This is adjacent to theta, right? So we'll take it as u cos theta. Any vector adjacent component is taken as vector cos theta, and this is perpendicular component, so we'll take it as vector sin theta. So x component is u cos theta, y component is u sin theta. Now it was projected, this was its upward journey. How long will it go? It will go till its highest point. This is the maximum height point of the projectile. And what is the maximum height? This is the maximum height. Is the maximum height along x-axis or y-axis? It is along y-axis. These observations are very important when we take the formulas of Hmax. Okay. And observe this pink color arrows. What do they represent? They represent x component of initial velocity. And at every point it is same, right? At every point along x-axis initial velocity is same. It is u cos theta, u cos theta, u cos theta, u cos theta and u cos theta. That means wherever you take for a projectile motion, the x component of initial velocity is same. It is u cos theta at any point. Now just see the length of the blue color arrow marks. They represent velocity along y-axis. So when the projectile is projected upward, what happens? Velocity goes on decreasing. Initially it goes on decreasing. At maximum height, the velocity of y component, it becomes 0. That means if I take this maximum height, here we have velocity only along x-axis, but there is no velocity along y-axis. Here final velocity is 0. I mean y component. And x component final velocity is same, that is u cos theta. And what about the downward journey? When the projectile is coming downward, velocity goes on increasing. Why this is the case? Initially it decreases, at maximum height it becomes 0, and in the downward journey it increases because the y components, if you take the velocities along y direction, that is because of Earth's gravity. Now if you take upward journey, the projectile is moving against the gravity, so velocity goes on decreasing. And during the downward journey, it is in favor of gravity, so velocity goes on increasing. Are you clear with these points? These points are very important. Adjacent component is vector cos theta, perpendicular component is vector sin theta. And angle of projection is theta. Always we take this angle of projection with the horizontal. And there is no change in velocity of the x component, but there is a change in velocity of the y component. Initially it goes on decreasing, it becomes 0 at maximum height, and then it goes on increasing. Are you clear with this velocity of y component? Now I want you to observe these 2 points. Let me denote it as A point and B point. Don't you think velocities are same here? U cos theta, U cos theta, U sin theta, U sin theta. That means at A and B points, the moment it was projected and the moment it touched the ground, at these 2 points A and B, the velocities are same, but there is a change in direction of y velocity, y component of velocity. Initially it was moving in upward, so plus, but later it is moving downward, so minus. There is only change in the direction, but magnitudes are remaining same. Important point, important observation. Clear with this? Now what about this distance AB call? The distance between initial and final points, the maximum distance covered along x-axis. What do we call it? We call it as range, denoted with R. So range is the maximum horizontal distance covered by the projectile. Once see this diagram, we'll just summarize what we have studied and we'll go to previous year question discussions. Fine. So parabolic path, 2D motion, everything fine with the projectile. Now we'll just split the data into x direction and y direction. What is initial velocity along x? It is u cos theta. And what will be final velocity? Apply this formula. V is equals to u plus at. So u is u cos theta. What is a here? If you see this diagram, along x velocity is not changing, u cos theta, u cos theta, u cos theta, so change in velocity is 0. So can I say that acceleration in x direction is 0? Since change in velocity is 0, velocity is remaining constant. So what will be final velocity now? It is just u cos theta only. Clear everyone? Now we'll do it in y direction. So initial velocity is u sine theta. And what about acceleration along y? It is accelerating due to gravity. So always it is minus g, because acceleration due to gravity is in downward direction. And what about final velocity? It is u plus at. Substitute the y components. U sine theta minus g into t. So this is your vy and this is your vx. Any difficulty? Please do understand, this is very important. And at maximum height, velocity at maximum height, it will be 0 along y direction, but it is not 0 along x. Got my point? Important. Now, so just memorize this data and I'll write an important point here. At maximum height in x direction, velocity is the same, u cos theta, but in y direction velocity is 0. At maximum height we have x velocity but y velocity is 0. Now we'll discuss some previous year questions. The velocity of a projectile at the initial point is, so this is the initial point, see the diagram, this is 2y plus 3j, its velocity at point B. So what will be the velocity at point B? See this, what we have discussed, at A and B velocities are same, but in y velocity there will be a change in direction. So it will be the same velocities 2i and 3j, but in y velocity there is a change in direction, so it will be minus 3j. 2i minus 3j. Answer is option A. Very important, Be confident, don't bother about these problems, because projectile motion, it looks difficult in the beginning, but once you catch the concept, this is the most easiest chapter. A particle of mass m is projected with velocity v, making an angle of 45 degrees with the horizontal. So what is this 45? This is the angle of projection. When the particle lands on the level ground, the magnitude of change in momentum, that means it was projected with this angle, let this be point A, it was landing again on the ground, let this be point B. Now at this point B, you have to find change in momentum. What is the formula for change in momentum? Change in momentum is m into change in velocity. This is 2D motion, so let's split into x and y components. So in x direction, change in momentum is equals to m into final velocity minus initial velocity. See, in x-axis, final, initial, at any point, velocity is what? Same. So it is u cos theta minus u cos theta. So what will you get? M into 0, it is 0. Now similarly do it in y direction. Change in momentum is equals to mass into change in velocity. So this is m into v minus u. So m into, what is the final velocity at this point? It is minus u sine theta. And here it is u sine theta. This is your v and this is your u. So just substitute. Sine theta is how much? Sine 45. Sine 45 is how much? 1 by root 2. So this is minus u by root 2. And this is plus u by root 2, because sine 45 is 1 by 2. Substitute it here. Minus u by root 2 minus u by root 2. So I will get minus 2mu by root 2. Can I write it like minus root 2 into mu? So this is along y. Now what about the net change in momentum, because this is 2D motion, right? How will you find the net change in momentum? It is square root of x component square plus y component square. So this is 0 square plus minus root 2 mu whole square. Let me rewrite it. Okay. So change in momentum net value is under root x component square 0, y component square, minus square is plus. Okay, first I'll write minus root 2 mu whole square. So what will you get? Root 2 square is 2, m square, u square. So what will you get again? You will get m into u and root 2. So this is the final change in momentum. But it was given in the question, initial velocity was v. So instead of mu root 2, you will get mv root 2. Answer is option A. Clear with this? Very simple. You are going to use the same formulas that we have dealt in 1D motion, but you are going to split it for x and y, and then you will take the net of them. See this question. A bullet is fired from a gun at a speed of 280 meter per second in the direction 30 degrees above the horizontal. Fine. So initial velocity is given 280 meter per second and angle of projection is given 30 degrees. The maximum height attained by the bullet. So what is our question? You have to find the maximum height. What is the maximum height formula that we have discussed in 1D motion? Maximum height is equals to u square by 2g. Now this maximum height is related to x component or y component? This is related to y axis, right? So what changes will you do here? Instead of u square, you must take uy square. You have to take uy square. Are you getting my point? Because height is related to x or y. It is related to y axis, right? So u square means here uy square. So find out initial velocity along axis y. It will be u sine theta. So sine theta is sine 30. So how much will you get? U upon 2 meter per second. Now just substitute. Maximum height is equals to U square. Initial velocity is how much? 280, right? Let us simplify this. 280 upon 2. How much will you get? 1 and 4, 0. So 140 meter per second. Now just substitute. So 140 into 140 U square by 2g. G is 10. So just simplify. How much will you get? What gets cancelled here? 0, 0 cancel. It will go for 7 times. You'll get 140 into 7. How much is this? This is 980 meters. So answer is 980. That means close to option B. Clear? So very simple. Just use maximum height is equals to U square by 2g. But which initial velocity are you taking? Y component of initial velocity. Now we'll move on to the next topic. Velocity of the projectile after time t. Let us imagine the same case. It was projected from point A with the angle of projection theta with the initial velocity u. So this is the x component u cos theta. This is the y component u sin theta. Now let us take this point of time. So at this its velocity will be different, right? Let this be final velocity. Now what will be the x component? It is same. Along x velocity is same. Now along y, will it be same? No, it is different. So what you have to do? Apply v is equals to u plus 80 in y direction. So this is u sin theta. A is minus g t. So you will have here u sin theta minus g into t. Any difficulty? Find out the final velocity using this equation. V is equals to u plus 80 and apply it for y components. So what will be the net velocity now? It is under root, or else we'll keep it in vector form. In problems we'll do this under root. So you can write it like x component u cos theta I cap and y component u sin theta minus gt into j cap. So this is your velocity of the projectile after certain time t. Will you do in this way? This is a concept, but what will you do? Just take x component, x direction, y direction. Apply v is equals to u plus 80 and take the resultant under root of x component square plus y component square. That's it. Now, if I take this angle, will it be theta here? What about the angle here? Let this be point B. It won't be theta, right? So let us take it as alpha. Now how will you find this angle alpha? Apply tan. Tan alpha is equals to opposite side to alpha by adjacent side to alpha. What is opposite side? It is Vy. And what is adjacent? Vx. Understood everyone? Sometimes they'll ask you what is the angle after time t. So just apply tan of the angle. Opposite by adjacent. So let's see this what we have done. You just take v is equals to u plus 80 for x and y separately. And remember along x the velocity is not going to change. At any point throughout the projectile journey along x velocity is u cos theta only. Because along x acceleration is what? 0, right? That's why. Now shall we do some problems? A particle starting from the origin moves in a straight line in the xy plane. So let this be the xy plane. It was starting from the origin and moving in a straight line. So this is the case. Its coordinates at a later time. What are its coordinates after some time? Root 3 comma 3. What does it mean? That means along x it was covering root 3 and along y it was covering 3. X comma y, right? So x is root 3, y is 3. The path of the particle makes with the x-axis an angle. So what is this angle? Can I apply tan of the angle? Let this be theta. What is tan theta now? Opposite side by adjacent side. So what is opposite? 3. And what is adjacent? Root 3. 3 by root 3 is how much? This is root 3. So when is the angle root 3 in tan? It is tan 60 degrees. So what is the theta now? Theta is 60. Answer is option B. Very simple, right? A bus is moving on a straight road towards north. Okay. With a speed, how much? 50 kilometers per hour. Then it turns left. Okay. Through an angle of 90 degrees. If the speed remains unchanged, that means this time also the speed is 50 kilometers per hour. The increase in velocity of the bus. Increase in velocity means what you have to find? You have to find change in velocity. That means final velocity minus initial velocity. So this was the initial velocity and this is the final velocity. It is v minus u. So what are we supposed to do? It is minus u. So you have to change the direction of u. So we'll do one thing. Initially u was upward, right? 50 kilometers per hour. This was initially u. And this is our final velocity direction and this is also 50 kilometers per hour. Now you have to change the direction of u. Instead of north, this time you have to take it towards south. Then it becomes minus u. 50 kilometers per hour. Magnitude is same, direction is reverse now. So v minus u. Now how will you find this v minus u? This is the resultant and this will give you what? V minus u. So just find out the resultant. What is the resultant? It is under root of a square plus b square because they are at 90 degrees angle. Or else, and this is equal vector, right? In the last class I told you, if it is equal vector, you can apply a square plus b square. Or if it is equal vector, what do we do? Vector into root 2. So vector is 50 and into root 2. So root 2 is how much? 1.414. Simplify this, you will get the answer as 70.7 kilometers per hour. Now what is this direction? What is the resultant velocity direction? This is west, this is south, and this is the resultant. So the direction is southwest. Answer is option A. I hope you are clear with this. Any difficulty? Now, two particles A and B are connected by a rigid rod AB. So this is the rod. Fine. Two particles are connected at A and B. The rod slides along the perpendicular rails as shown. So at A point, this is the direction. At B point, this is the direction. The velocity of A to the left. What is this? This is 10 meter per second. What is the velocity of B when angle is 60? So angle is given. Velocity at A is given. You have to find velocity at B. Can we simply apply tan theta formula? So tan 60 is equals to opposite by adjacent. Tan 60 is how much? Root 3. What is at opposite side? Velocity of B. What is at adjacent side? Velocity of A. So what is VB now? 10 into root 3 meter per second. Okay, root 3 was substituted here. So 10 into what is root 3? 1.732. You are doing into 10. So one decimal will shift. So it will become what? 17.32 meter per second. Approximately 17.3. Clear? See how simple the questions are. Now we'll see some important formulae. First we'll see time of flight. What is time of flight? Formula that we have discussed in 1D motion, it is 2u by g, right? And what is this time of flight? It is the time for which the body remains in air and it is related to vertical motion. So u place what you have to do? You have to take uy by g. So that means 2u sine theta by g. You should remember this formula directly. Time of flight is 2u sine theta by g. Same formula 2u by g only, but u place you have to take y component of u. Now next we'll see maximum height. Maximum height formula is what? U square by 2g. But which u we will take? We'll take y component. So it is uy square by 2g. So it is u square sine square theta by 2g. So directly remember this. Remember the same formula but take y components. Then we'll take range. What is range? It is 2 ux component, uy component by g. Or you can remember u square sine 2 theta by g. Remember them fast. I want you to remember the 1D formulas only. But what you have to take? You have to take y components. And here also u square by 2g only, but y components. So finally you will get this formula 2u by g, u square sine square theta by g. This is a new formula, so remember, important. You will have questions on this. 2ux uy by g, u square sine 2 theta by g. Just take half minute time and memorize them. Done? Okay. Now we'll see next formulas. See, when angle of projection is 45 degrees, then the range of the projectile will be maximum. And this maximum value of range will be equal to u square by g. How do we get this? Just substitute in the range formula. Theta is 45, 2 theta is 90, sine 90 is 1. So I'll get u square by g. And remember, when the range is maximum, this is the projectile motion, right? Imagine this is maximum range, and what is this? This is the maximum height reached by the projectile. If range is maximum, that means if theta is 45 degrees, then at this maximum height point on the x-axis, these distances will be equal. That means this is r by 2 and that is also r by 2. Are you getting my point? If angle of projection is 45, the maximum height point on the x-axis, it will divide the range equally, r by 2, r by 2. And what is the relation between height and the range? 4 times the maximum height is equals to r into tan theta. 4 times the maximum height is equals to r into tan theta. Remember this. Clear? Now, we'll move on to previous year questions. The horizontal range and the maximum height, range and the maximum height of the projectile are equal. The angle of projection of the projectile is, what is equal here? Which are equal here? Tell me. Horizontal range r is equals to maximum height of the projectile. So just substitute the formulas. Range is what? U square sine 2 theta upon g. Maximum height is u square by 2g. But which u square you have to take? Uy. So u square sine square theta by 2g. Can we split this? Sine 2 theta is what? 2 sine theta and cos theta. This is the formula of sine 2 theta by g is equals to u square sine square by 2g. What gets cancelled here? Cancel the terms. U square cancel. G cancel. 1 sine theta and sine theta cancel. What is left here? 2 cos theta. And here we are left with sine theta. So send cos theta that side. What will you get? 2 is equals to sine theta by cos theta tan theta. So what is theta now? It is tan inverse of 2. Did you get this answer? Are you trying first on your own? Did we miss anything? Tan inverse 2. We have missed this right here, sine theta upon 2. So this is not 2, this is actually 4. That is what I was thinking. Something is missing here. See, on the right side, it is sine theta by 2, right? So it is 2 into 2, 4. So theta is equals to tan inverse of 4. Clear? So answer is option B. See, tan inverse 2 is also there. So we have to be very careful. If you miss out even small numbers, you will not get the right answer. A missile is fired for maximum range. Maximum range means R maximum is equals to U square by G. And what will be the angle of projection? It will be 45 degrees. Initial velocity is given, G value is given, the range of the missile. You just have to find out the maximum range. Substitute R max is equals to U square. That means 20 into 20 upon G. G is 10. 0, 0 cancel. We'll get 20 into 2. That is 40. So what is the maximum range of the missile? It is 40. Option A. A projectile is fired at an angle of 45 degrees. What is the angle of projection? 45. That means, don't you think this is the maximum range case? With the horizontal elevation angle of the projectile at its highest point as seen from the point of projection. Read the question once. Try to understand it. Elevation angle at the highest point seen from what? Seen from point of projection. So let us understand it diagrammatically. This is the horizontal projected with angle how much? 45. So it follows a parabolic path and it will fall back to the ground. So let this be the maximum height. Maximum height point. Now, what is this elevation angle? It is the angle made at this highest point and seen from point of projection. So, you are seeing from here. So, from the point of projection to the maximum height point, what is this angle? This is called elevation angle. Let it be alpha. You have to find this alpha. Now, can I apply tan theta concept? So, tan alpha is equals to opposite upon adjacent. What is opposite to alpha? It is maximum height, h max, upon. What is adjacent here? For 45 degrees, this maximum height point on the x-axis, it divides the range equally, right? So this is r by 2 and this is also r by 2. So what is adjacent now? R upon 2. So just substitute the data. What is maximum height? It is u square sine square theta by 2g. Substitute u square sine 45, theta is 45. So sine 45 is 1 by root 2. It's a square, so it will be 1 by 2 upon 2g. So what will you get? U square by 4g. Any difficulty? This is the maximum height. Just take the formula, substitute the value of theta. Now similarly find out the range. What is the range? Maximum range? It is u square upon g. So just substitute all the data. H max is u square upon 4g divided by r by 2. R is u square by g and already we have 2 in the denominator. So simplify this. How much will you get? U square cancel. G cancel. 2 ones, 2 twos. So you are left with only 1 by 2. So tan theta is 1 by 2. So what about theta now? It is tan inverse of 1 by 2. Clear? So this is the elevation angle. Just see once what we have done. I'll draw the diagram neatly. Just give me a time of 1 minute. Meanwhile, you just go through what we have done. How did we solve this problem? So this is the maximum height point. This is H max. So it divides the range equally. So this is R by 2 and this is also R by 2. And from the point of projection to the maximum height, this is your elevation angle alpha. Clear? So just take the tan alpha, opposite h max, adjacent r by 2. Take the respective formulas of h and r, substitute, simplify, you will get the answer as tan inverse of 1 by 2. Option C is the answer. See this question, the speed of a projectile at its maximum height is half of its initial speed. See, at the maximum height of the projectile, we have only x component velocity, that is u cos theta, and along y, what is the velocity? This is the maximum height point. At h max along y there is no velocity, it is 0 meter per second. So we have only u cos theta speed. So this speed at maximum height is equals to half of the initial speed. Let us imagine that it is projected with initial velocity u, half of the initial speed. You have to find angle of projection. So you cancel. You'll get cos theta is equals to 1 by 2. How can we write this 1 by 2? Is it cos 30 or cos 60? Cos 60. So theta is how much? 60 degrees. Answer is option A. Very simple. The maximum range of a gun of horizontal terrain. So maximum range is given 16 kilometers. What is maximum range first of all? It is u square upon g, and this was given as 16 kilometers. That means 16 into 10 power 3. G value is 10. Then the muzzle velocity of the shell. Muzzle velocity means initial velocity. So everything is ready. Just simplify. U square is equals to what? 16 into 10 power 3 into g. G value is 10. So can I write it like 16 into 10 power 4? This is u square. Now what is u? Square root of them. So square root of 16 4. Square root of 10 power 4 is 10 square. So what is the answer? It is 400 meter per second. Answer is option C. Now, a horizontal bridge is built across a river. Let this be the river, and that was the surface. Some bridge is constructed. Let us imagine this is the bridge. Fine. A student standing on the bridge. Let this be the student. That means this is you only. Good student preparing for your NEET exam. So throws a small ball vertically upwards. So ball is projected vertically upwards with the initial velocity. How much? 4 meter per second. The ball strikes the water surface after 4 seconds. That means after 4 seconds, if you see the ball, where is the ball? It was projected upwards, it will reach its maximum height and then it will fall back, right? And this was on the water surface after 4 seconds. So what is the height of the bridge? You have to find this height. How do we find the height of the bridge? See the question carefully. Initial velocity is available, time is available, and these are the positions. This is x initial, this is x final, final position. Can I say now this height is nothing but displacement of the ball? So height of the bridge is nothing but the displacement, and displacement is what? Ut plus half a t square. Now if you see, displacement is negative because the final position of the ball is below the initial position. So I'll write it as minus h. U is positive because it is going upward. So 4 into time is 4 seconds again. Plus half. A is what? Minus g. T square. 4 square is 16. Simplify. 4 fours are 16. Minus 2 ones, 2 8 times. So how much will you get? So it is minus 80. 16 minus 80, how much? It is minus 64. So minus h is minus 64. Minus minus cancel. So h is how much? 64 meters. Clear with this? Very simple. We are still using the equations of motion only. You have to find the height of the bridge. That's nothing but displacement of the ball. And follow the sign convention. Okay, so 64 meters. This is the height of the bridge. A bullet from a gun is fired on a rectangular wooden block with a velocity u. Just take 1 minute, just give me 1 minute time. I'll just switch on the charger to my laptop. Meanwhile, go through this question, everyone. If you can solve it, try to solve it. Yeah. Have you gone through the question? Understood anything? You will definitely. A bullet from a gun is fired on a rectangular wooden block. Okay. Let this be the rectangular wooden block. Bullet was fired with the initial velocity how much u. So this is the initial velocity. Bullet travels how much? 24 centimeters through the block. So how much distance it has traveled? 24 centimeter. Velocity of bullet becomes u by 3. That means after traveling 24 centimeters, at this point, let this be A point. Let this be O point. OA is 24 and speed at O is u. What is the speed at A? It is u by 3. Then it further penetrates into the block, fine, in the same direction, fine, before coming to rest exactly at the other end of the block. So this is the other end of the block, let it be B. It is coming to rest here, that means its speed is 0 meter per second. Now it has traveled this distance further, AB distance. Now what is the question? Total length of the block. How do we find total length of the block? Can I say it as OA plus AB? Already we have OA as 24 centimeters. Now let us find out what is AB distance. And then you can add up and you'll get the length of the block. Very simple. At O, speed is u. At A, speed is u by 3. At B, speed is 0. OA distance is 24. Find out AB distance and just add them. OA and AB. You'll get the answer. So how shall we find this AB distance? We'll do one thing. We'll split it to two parts. Let this be first part. Let this be second part. First, we will take OA part. Initial velocity is u only. Final velocity is u by 3. And S is 24 centimeters. So 24 by 100 meters. What is acceleration here? We don't know, right? So find it out. Use this formula. V square minus u square is equals to 2as. So V square, it is u square by 9. U square is u square only. 2 into A into, what is S here? 24 upon 100. So u square minus 9u square, you'll get minus 8u square by 9 is equals to 48a by 100. So what will be A now? We'll just simplify this. 8 ones, 8 6 times. So A is equals to 100 by 6 into u square by 9 and minus. Why minus? Because it is going to stop, right? That means it is actually deacceleration. Acceleration is in opposite direction. So you got this A value. Keep it on hold. Take it as 1. Now take this part, second part, A to B. A to B. What was the initial speed? U by 3. What was the final speed? 0. And what is the distance? We don't know. What is the acceleration? It's the same, right? Minus 100 by 6 into u square by 9. So use the same formula. V square minus u square is equals to 2as. This is 0 square. This is minus u square by 9. This is 2 into minus 100 by 6 into u square by 9 into s. We don't know this. So what gets cancelled here? Sorry. Minus cancel. U square cancel. 9 and 9 cancel. 2 1 times, 2 3 times. So left side nothing is left 1, and right side it is 100 by 3 into S. So what is S now? It is 3 by 100 meters. If I convert it into centimeters, 3 by 100 into 100 centimeters. 1 meter is 100, right? So I'll get 3 centimeters. So you got the AB distance now. This AB is how much? It was 3 centimeters. Now what is the total length of the block? It is 24 plus 3. So it is 27. Very easy. You are all the time using equations of motion only. But you must be aware of how to apply them. So understand the question. That will automatically help you how to use the formulas. Now we'll see one more concept, last concept for today's class. Complementary angles. What are complementary angles? Let me take sum of two angles as 90. First angle plus second angle is 90. Then what do we call these two angles? These are complementary angles. That means any two angles whose sum is 90. What do we call them? We call them as complementary. Those angles whose sum is 90 are called complementary angles. What we have to understand for our projectile motion is, imagine initial velocity is same and mass is also same, but there is a difference in angle of projection. Theta is different. Let us consider two particles whose initial velocity, mass, everything same, but angle of projection is different. And those angles of projection summation is 90. Theta is different, and if the theta sum of two different particles is 90, that means if it is complementary angle, then we will follow these formulas. Their ranges will be equal. R theta, R 90 minus theta. If first angle is theta, what is second angle? If they are complementary, 90 minus theta, right? Similarly, if you take height ratio, h theta by h 90 minus theta, it will be equal to tan square theta. When I'm writing, try to memorize the formulas. And product of the time taken by them is 2 into r upon g. Which r will you take, r1 and r2? Both are same, na? That was the first point. Two ranges will be equal. Height ratio will be tan square theta, and product of the times taken will be 2r by g. Remember the formulas. When we do problems, you'll understand. This is very important because most of the previous year questions in NEET was based on first formula. If the angle of projections, two angles of projections, if they are complementary angles, then the ranges are equal. Shall we do the problems? If a body A of mass m, okay, thrown with the velocity v at an angle 30 degrees to the horizontal, and another body B of same mass with the same speed projected at an angle of 60 degrees. That means everything same. And just see this angle 30, 60. What about their sum? It is 90 degrees, right? So what are these two angles? They are complementary angles. The ratio of horizontal range of A to B. That means range of A by range of B. First of all, ranges are equal because they are complementary. So what will be the ratio? 1:1. See how simple it is. For angles of projection of a projectile, same concept, two different angles. The horizontal range described by the projectile or in the ratio. You have to find the ratio of the range. Ranges will be equal because what is the summation? 45 minus theta plus 45 plus theta minus theta plus theta cancel. Sum is coming out to be 90. So they are what? They are complementary angles. And for complementary angles, ranges will be equal. So ratio will be 1:1. Two projectiles of same mass with same velocity. Mass is same, initial velocity is same, but angles of projection 60 and 30. Then which will remain the same? 60 plus 30, how much? 90 degrees. So which angles are they? Complementary. So what is equal? R theta is equals to R 90 minus theta. That means their ranges are equal. So range of projectile will remain the same. Clear? Everyone? Any doubts in today's class? If so, kindly comment so that I will help you. So I hope you are clear with today's session. So let's quickly recall what we have done. We have discussed projectile motion and solved important previous year questions. And please do remember, if the velocities are given, resolve them into horizontal and vertical components. And also remember, for a projectile motion, horizontal motion is uniform, but vertical motion is accelerated due to gravity. And also make sure you remember the standard formulas for maximum height, time of the flight, range, because these are directly used in many questions. You have seen, right? Today we have discussed. Most of the questions are directly formula based. And one more important result, for complementary angles, the range remains the same. This is a very common exam question. You can see 3 questions are there on this: 1990 and 2006, 2000. So revise these questions once again and try to practice similar questions from your end. In the next session, we'll continue with more applications of motion in a plane. We will discuss trajectory motion, trajectory of the particle, and we'll see projectile from certain height, and we'll see projectile from a height at some angle. So we'll see all other different concepts left over in this chapter. So thank you so much, and I'll see you in the next class. Have a good day.